Suppose you have a bag, and in that bag you have 3 blue pens and 5 green pens. That we are just giving as an example. Now, use probability tree diagram to generate the sample space. First of all, here we have 2 events. There are 2 things we expect. There are 2 possible outcomes. You either pick a blue or you pick a what? A green. So those are the only 2 spaces we have. But we have 3. What's the chance that you pick blue? If we are picking it only for the first time, there's no need for us to draw a probability tree diagram because that one will be straightforward. But if you are picking more than once, so then it will be easier for you to use a probability diagram to generate for you a sample space and to generate the outcomes because you are doing it more than once. But if you are getting it straightforward, then it will become easy. Okay? And we have said we have 2 scenarios here. First of all, you need to know the number of items or the number of pens in that particular container, like we are using a box. So in the bag, sorry. So we said there are 8 pens. So now, what are the type of selections? There are 2 types of selection because we are going to be selecting randomly. You're going to be selecting what? Randomly from the bag. So what is the chance that you will pick a blue? What is the chance that you will pick green? So now from here we are saying that, take for example, you are being told that to pick or select at least twice or 2 times. So which means there are 2 things that may happen. You may either pick, then you fail to take it back, or you pick and then you take it back. Now, when you pick and you take it back, that one we call it with the replacement. We call it with what? Replacement, which means the number of items in that bag or in that container will remain the same or will remain constant. But if you are picking and you're putting it, you pick after picking one at a time, you pick one at a time, you pick one, you put it aside, which means the number of items keep on reducing or keep on decreasing. That one we call it picking without replacement. And now we were looking at the first case. We are saying, take for example, we are taking with replacement, which means you pick, you take it back, which means the number of items in that particular container will remain the same, But how do we use now probability tree diagram to generate the sample space or to generate the possible outcomes? So now from here we shall say, now you multiply along the line, along the branch. You multiply along the what? The branch. So this is our first branch, this is the second branch, this is the next one, this is the next one. So which means you start from where you started from. So for the first time you pick blue, again for the second time you pick blue. So which means this one, we multiply them. So this is the probability of B, which means the same color, B and a B. And means multiplication in mathematics. This is probability of picking blue and green. Blue and green. What about this one? This probability, the chances of you picking green and blue in that order. This is the chance of you picking green and green. So now to get the probability now, you multiply each branch. So we are going to have 3/8 times 3/8. What do we get? What do you get, members? What do you get? 3/8 times 3/8. You find out shall have 3 times 3, that is 9, not so? Over 8 times 8, which is 60. 60 what? 64.
64.
Then we have 3/8 times 5/8. This one, 3 and 3 will give us 15.
15.
Out of 60 what?
64.
Out of 64. Then green and blue. So we shall have 5/8 times 3/8, which will give us what? 15 out of 60.
15 out of 64.
Then 5/8 times 8, 5/8. That one will give us what? 20. 25 out of
64.
25 out of 64. Now, there's something very interesting here about probability. When you add each branch, each what? Members, each what? Each branch must give you 1. Like now, this is our first branch, this one and this. This is the first one. When you add 3/8 plus 5/8, what do you get? Is it not 1, members? Is 1, not so? Then this branch also, when you add 3/8 plus 5/8, is it not 1? Is 1. Then when you add this one and this one, is also what? 1. Then another effect is that when you add all this probability, total probability must be a wall. Must be a what? A wall. So now, when you add, let me say here, not, when you add a probability of getting blue and blue plus probability of getting blue and green plus probability of getting green and blue plus the probability of getting green and green must give you 1. Must give you what? Must give you 1. Are you together? Members, can we prove it? Because that concept is very important, because it's the one going to determine whether we are on the, whether we have drawn our probability diagram correctly or not. What was the probability of getting blue and blue? It was what? 9 out of 25 plus. What about blue and green? Blue and green we got. What was blue and green? It was 15 out of 64 plus green and blue was 15 also out of 64 plus green and green we got 25 out of 64.
25 out of 64.
But when you add this, must give you 1. Is it true? Can we prove that? Can we prove that? Can we prove that, members? So I have 9 over 25 plus 15 over 25. I mean 64, sorry. Plus 15 over 64 plus 25 over 64. What has happened? Sorry. I have 9. I'm wondering where are we getting this 25 from? It's supposed to be 64. Sorry. This is supposed to be 64. That's why it was giving me different thing. So it's 9 out of 64 plus 15 over 64 plus 15
over 64
plus 25
over 64.
You can see that it's giving us 1, not so?
1, yeah.
Which means we have drawn our probability diagram correctly. That means we have drawn our, yes. Now, if that one is true now, we can use it now to answer the same, we can use it to answer any question now. We can use it now to answer what? The question that may come. The question they may ask, what is the probability? Find the probability of getting or picking the same, of picking there, let's say number 1, the same color. The same what? The same color. Now, the same color here, what are we talking about? Which means you can either pick, is going to be what? Probability of same color. We say probability of the same what? Color is going to be, which means must be blue and blue or green and what? So here can be green or what? Or what? Green or blue. Green or blue. And or in mathematics mean addition. Or means addition. So which means it's going to be probability of getting green and green plus probability of getting blue and what? And blue. So what was the probability of getting green and green? From here, you come and check from here, from your tree diagram here. Green and green was what? 25 out of 64. Then blue and blue was what? 9 out of 64. So you combine them together. So which means we give us, sorry, this will give us 25 out of 64 plus 9 out of 64. So you find out a probability of the same color, probability of the same what? Same color will be, they have the same denominator, you just add the denominator, which is what? 25 plus 9, what do you get? You get 34 out of 60. 34 out of 64. But you still add a common factor there. Can you reduce it? 34 divided by 64. You get that. But what is it in fraction? You get what? 17 out of 30 out of 32. Are you together? Then Roman 2, we can set Roman 2. Different color. What is the probability of getting different what? Different color. So which means probability of getting different color, different color would mean you can either get, it means you can get blue and green, not so members, or you get green and blue, but you cannot, not the same color, but different color. So which means we are taking only these two. We are taking only these two. So which means it's going to be probability of getting green and blue plus oro, let's use oro, green, and blue. And we said oro means addition. Oro means what? Addition. So probability of green and blue plus green and blue, like that. But what was the probability of getting the two? It was what? 15 out of 64 plus 15 out of 64. So when you add this one, what do you get? You get 30 out of 64. If you simplify, what do you get? 30 divided by 64. You get what? 15 out of 30? 32. Are we together? Members, are we together?
Yes.
All right. All right. So put some note here. Note. In probability, put it in quote, oro is union, that is addition, and put it in bracket, in quote, and means intersection, that is multiplication. That is what? Multiplication. Can you underline them? This and then that. So in a nutshell, if you said oro means you must what? You must add, and means you must multiply. That is multiplication. That's what I'm talking about. So if they said, what's the probability of getting A and A? So which means you have to multiply the probability of getting A and A. But if they said, what is the probability of getting A or a B? So which means you must what? You must what? Add. Are we together, members?
Yes.
Yes. Good. So like I was explaining for you from here. So to generate the sample space, you multiply along the branch. You multiply along the what? You multiply along the what? The branch. So let's go to more examples now. That's max. Let's go to more examples now. Hey, this one is like we have done. This is the same as we have done. Like here now they're asking, what's the probability of getting two green balls? That one is easy. This one is what I've explained already. When the required outcome is given by the path along, multiply the probability along the path. When the required outcome is given by 2 or more, you add. That is it, oral. So let's look at this question here. I think this example here, members. This is what we have just done, or what we have seen up there. That's what we have seen up there. This time, let's look at this. But what we did here was with what? Here was with replacement. Now let's discuss one where there's no replacement, without replacement. Case number two, without replacement. So our blue pens still remain 5. Then our green pen still remain what? 3. So total number of pens in the bag will still remain 8. So this time we are using the same example, but using different concepts. The first one was with replacement. Now we are looking without replacement. So let's look at the probability tree diagram. Probability tree diagram for that. Probability tree diagram. So this is our bag. Which we have blue and green pens inside. So if I pick, so the first branch from there, You can get a blue or you get what? A green. That is our first picking. That is the first one. That is the first one. So what is the probability of getting a blue? Will be 5 out of 8. Then what is the probability of getting a green? Will still also be 3 out of what? 3 out of 8. That is the first picking. Now the second one, because they told us they were picked twice, in the second picking now, members, it will be like this. Like that. Make sure you are smart in your work. Draw a good one. Draw a smart one. Draw a smart one. Like that. So you get blue, green, blue, green. This is the second one. This is the first one. Then this is the second picking. Members, are you following me? Cynthia?
Yes, teacher.
All right. So now what we are going to do, assume here in the first branch, we assume that we have picked a blue. So if I've picked a blue, remember you are picking without replacement. You are picking without what? Replacement. So which means we shall have, you will have 4 out of what? Out of 7, not so? You will have 4, because now there were how many blue? There were 5 blues. Now you have picked 1, which means you remain with only what? 5? You remain with only 4. You did not pick what? You did not pick green. So which means the number of green will still remain 3. So it will be 3 out of what? 3 out of what?
3 out of 7.
3 out of 7. Then you come and do the same here. In the second branch, you assume that you have picked what? Green. Assume that you have picked green. If you have assumed that you have picked green, which means green will be what? Will be 2 out of what? Will be 2 out of 7, because there were 3. Now, you did not pick what? You did not pick blue. So which means blue will still remain 5. It will still be 5 out of what? 5 out of 7. Like that. So now proceed. Create a probability here. Create a probability there. So we shall have, this is probability of blue intersection. Blue, I say intersection mean multiplication. So this probability of blue intersection green. This probability of green and blue. This is a probability of green and green. Sorry, and green. Continue multiply the probability in each branch to give you a clear picture there. So what is the probability of getting blue and blue? So you're going to be 5 out of 8 times what? 4 out of 7. So what do you get? So this one will give you 20 out of what? What is 8 times 7? That is 56. 56. 8 out of 5 times 3, this will give us 15 out of 56. You come to this will also give us 15 out of 56. Then this one will give us 6 out of 56. Out of 56. Now, can you add these? If you add this, must give us what, members? If you remember, I said if you add all of this, must give us what? Must give us 1. So can we add? So they have the same denominator, 56. Let's just add the denominator. So 20 plus 15 plus 15, then plus 6 is 56, not so? 56 out of 56, that is 1. So we are correct. That one we are correct. So now the question is, find the probability of getting or picking part A, let's say the same color. Same color. So probability of the same color will be probability of getting blue and a blue, or green and what? Green and green. So which means the same as B intersection B plus, I said or means addition, green and green. So from our working, what did we get? what was the probability of getting blue and blue? Was 20 out of 56, right?
Yes.
Plus, what about green and green? Green and green was 6 out of
6 out of 56.
They have the same denominator, just add the denominator. When you add that one give us 26 out of 56. Are there common factors? Simplify it. Simplify that. 26 divided by 56. That one is what? 13 out of 28. Is it the same? Do they have the same answer, members? Here, with replacement, we got same color as what? 17 out of, we got 17 out of 32. But without replacement, we got 13 out of, so the chances are different. Have you seen that? Members, have you seen that?
Yes.
Yes. B, different color. Different color. Different color. So different color, probability of getting different color. Different color. Different color will be equals to probability of getting, you get blue and green, or you get green and what? And a blue. These two, you get this one. Because they're saying different color. Different color. So which will give us this probability of getting blue and green, plus probability of getting green and that, which is 15 out of 56 plus 15 out of 56. When you simplify that, you'll get 30 out of 56. 30 out of 56. But there is a common factor there. If you simplify that, this will give you 15 out of 20 out of 28. 15 out of 28. Remember, is that what we are getting also?
Yes.
So those are the two cases, with replacement or without replacement. Any questions so far? Members, any questions so far? Like here, they can also ask, let's look at part C. What's the probability of picking 2 blue pens? Probability of picking 2 blue pens. 2 blue pens. So probability of picking 2 blue pens is just going to be probability of what? Probability of, which means blue and what? Blue and blue.
Blue
So,
and blue.
So for blue and blue, we got what? What was the probability for blue and blue? What did we get? From the tree diagram. We got 20 out of
20 out of 56.
20 out of 56. Can you simplify that? Can you simplify that? By 2, we get 10. By 2, we get 20. 28.
28.
Again, there's still common factor there. By 2, we get 5. By 2, we get 14. So it's 5 out of what? 14. Members, have you seen that?
Yes.
Yeah. So is there any question? Is there any question so far? Because I want now to ask to go and do more questions now. Here. Exercise here, okay? If there's no question, let's start with, I think that question that you are seeing on your screen. Question number exercise, under exercise. Are you seeing them?
Yes.
Let's do number 1. Actually, we are through now. Let's just do more examples. More what? More examples. Number 1. They're saying a bag contains 5 red balls. 5 red. We have red balls. There are how many? There are 5. Blue balls. There are how many? There are 3. Then yellow.
There are 2.
Yellow, there are 2. So how many balls? Total number of balls. Total is what? It's going to be 3.
10.
Plus 5 plus 2, which is what? 10.
10.
So what have they said? They have said a ball is drawn and not replaced. And not replaced. What is that? Is it with replacement or without replacement?
Without.
That is
replacement.
without replacement. So without what?
Replacement.
And we said if it's without replacement, which means the number of balls will what? Will keep on what? Reducing, not so? The number of balls will keep on reducing. So let's draw probability tree diagram. Probability tree diagram. So give enough space for your work, please. Give enough space. Because this time there are 3 in numbers. There are 3. This is what I have. I have red, I have blue, and I have what? Green. So
Yellow.
I mean yellow, sorry, yellow, sorry. How many times was the ball drawn? How many times? 2 times, not so?
Yes.
So we have red, blue, and then yellow. So that was the first time. That was the first time. So what is the probability of picking blue? I mean red is going to be what? 5 out of 10, not so?
5 out of 10.
Blue is going to be 3 out of 10.
3 out of 10.
Yellow is going to be 2 out of 10. Now you go for the second picking. You pick for each branch. For each what? For each branch. So like that. Like this. Like that. Like this. Let me create 3 here. I want to create 3 here. Like that. Like that. Like this. Like that. Like that. Okay? So this is it. Red, blue, yellow. Red, blue, yellow. Red, blue, yellow. Okay?
Yes.
So we are going to assume. We are going to what? Assume. In the first branch, are you seeing this first branch members here? I'm going to assume that I've picked red. I've picked what? Red. So if I pick red, which means the number of red will reduce to what? Will reduce to 4. Out of 4 out of what? The number of balls will also reduce to what? To 9.
9.
I did not pick blue, which means the number of blue will still remain 3 out of what? 9. I did not pick yellow, which means yellow will still also remain 2 out of what? 9.
9.
Now, when you come to the second branch, assume that you have picked what? Blue. Assume that you have picked what? Blue. Which means red will remain 5. Red will still remain 5 out of what? 9. Okay?
Yes.
Blue will reduce to what? Blue will reduce to 2 out of
2
9.
out of 9.
Then yellow will still remain 2. Yellow will still also be 2 out of 9. Okay?
Yes.
When you come to the third branch, assume that you have what? Pick what? A yellow. Assume that you have picked what? Yellow. So if you have picked yellow, which means yellow will be what? 1 out of? 1 out of what? 1 out of 9. Then blue will be what? Blue will remain 3 out of 9. Then Red will be 5 out of 9. Have you seen that, members?
Yes.
That's how we work it out. So which means we shall have this is probability of getting red, red, and red. Okay? This one is probability of getting. Hey, sorry. How many times? This is only one, right? Red and red. This is it. Red and what? Blue. This one is it. Red and what? And yellow.
Yellow.
Then this one will be blue and red. Then this one will be blue and a blue. Then this one will be blue and what? Yellow, right? Follow the branch.
Yes.
This one will be yellow and red. This one will be yellow and a blue. Then this one will be yellow and what? And yellow.
Yellow.
Good. So let's start multiplying the branch. Let's start multiplying the branch. Red and red will be 5 out of 10 times 4 out of what? 9. That one will give us what? Will give us 20 out of what? 90. Not so. Then this one will give us, this time this will give us 15 out of 90. What about this? This one will give us 10 out of 90. This one will give us 15 out of 90. Then this one will give us 6 out of 90. This one will give us, we have skipped out one here. That will also give us 6. It will also be 6 out of 90. Here. That one will be 10 out of what? 90. Here will be 6 out of 90. This one will be 2 out of 90. Members, have you seen that? Have you seen that?
Yes.
So can we add all of them? We said before even you go to answer any question, first look at whether this one, if you add this probability, must give you 1. So they have the same denominator. Let's add the denominator only. We have 20 plus 15 plus 10 plus 15 plus 6 plus 6 plus 10 plus 6 plus 2. You get what? 90. 90 out of 90 is what? 1. No, sir?
Yes.
So which means we are correct. We are correct. So what is the first part of the question? Part A of the question. They're saying what? 2 red balls. 2 red balls. We have